Hey, and welcome to this lesson about sets and Venn diagrams. This lesson, we're going to talk about what a Venn diagram is and what exactly a set is in math. First, let's talk about Venn diagrams. I'm sure you've seen them before, but in math, Venn diagrams are a way of picturing relationships between different groups of things. The mathematical term for a group of things is a set, a mathematical set. Here we have a Venn diagram of different types of polygons or shapes. You have different sets here. You have the set of rhombi, which is the plural term for a rhombus. You have the set of rectangles. In here you have the intersection, which we'll talk about a little later, but it's a little set subset. We'll talk about that later too, but it's squares are both rhombus and a rectangle, so therefore they're in both of those two sets. You have the smaller sets that are in the bigger sets. All the rhombus, squares, and rectangles, they are all parallelograms. All parallelograms are types of quadrilaterals. You have a bigger set out here. You have other sets that don't have anything in common, so there is no intersection. But they are sets all the same, and they're separate. They're not parallelograms, so they're not over there, but they are quadrilaterals. They're sets of their own. First thing about sets that I'd like to talk about, I kind of hinted at this on the last slide, is what's called an intersection. So when a thing belongs to two sets at the same both at the same time, then we call that thing, or we say that thing is at the intersection of those two sets. So if I have something that is both in set A and that's the key word there, is and. Whenever you see and, you should think intersection. So if I have something that is in set A and set B, then that thing is at the intersection of A and B. So this is the intersection of A and B. Think of it as where the shapes overlap, or whatever the sets overlap. And like I said earlier, an example of this is a square. It is both a rhombus and a rectangle. Therefore, it is at the intersection of both the set of rhombus and the set of rectangles. Now, when a thing might belong to either or of two different sets, then we say that thing is at the union of the two sets. So a union of two sets is when one thing can be in either set A, we're either in set A, or we're in set B. So it could be anywhere, not just where they overlap. It could be anywhere in set A and anywhere in set B. Now, different sets have different sizes. So I want to talk about two things. The first thing is what's called a subset. And when an entire set of things, or whatever's in that set, is part of a bigger set of things, and that's the important part. The entire set is just part of one bigger set of things. Then we say that smaller set is the subset of the bigger set. So in this example, we have set B, and all the things inside it is really just a small portion of the entire set of A. So set B is the subset. It's smaller, so the subset of A. Set A. And like we saw on the example earlier, all parallelograms are really just a subset of types of quadrilaterals. And now the opposite, when an entire set of things is part of a bigger set of things, then we say that the bigger set is the superset of the smaller set. So, same scenario, now A is the superset of set B. So B is the subset, and A is the superset. In the example of different types of shapes, quadrilaterals would be the superset of parallelograms, and parallelograms would be the subset of quadrilaterals. That's all for this lesson. Make sure you go try your assignments. If you're confused about anything, please go back through the video, watch it again, take notes. If you still have questions, come to live class. We'll go over this a lot more, do some more examples, walk you through problems. If you're still not getting it, come to Math Cafe. We'd love to help you out as much as we can.